Welcome! In the second part of lesson 3, we'll look at another logical operator, the biconditional operator. We introduce a new law to simplify this operator, and we'll have a look at some priority rules. Okay, let's start with the new propositional operator, the by implication, and with this symbol here. If you compare it with what we've all done and used in when we proved something, we tried to prove something, we use this equivalence operator. So the difference between the biconditional and the equivalence is that this is just one line. So this operator, this biconditional operator, is defined as follows. If both values are the same, so if they're both 1 or if they're both zeros, then the by implication will give us a true. If they differ, then the by implication will give us a false. So in fact, by implication is true only if the both corresponding propositional values have the same value. So either they're both 1 or they're both false. Again, if we look at this by implication and we try to simplify compound statements, it's quite difficult to work with. So that's why someone thought of this law, the switcheroo 2 law. And again, to prove that this one is really true, we'll just make a truth table. So we have 2 propositions with 4 possible combinations. So we have PQ with 4 different value sets. So let's start with the column given with the by implication set, because that's just given with the definition. So a by implication is true when the values are identical and false in all other situations. Okay, then let's look at the right side, P and Q. So P and Q will give us a true and a false in all the other rows. Okay, then we have not P and not Q. So let's first do not P. That gives us 0, 0, 1, 1. Then let's look at not Q, which gives us 0, 1, 0, 1. And then the combination not P and not Q will give us 0, 0, 0, 1. Okay, then we need to do the last one. So P and Q, let's call this one 1. And not P and not Q, let's call it 2. And then 1 or 2 will give us 1, 0, 0, 1. Okay, and then we need to show that both columns are identical. And indeed, that's true. Check. So switcheroo law 2 applies, and from now on we can use it to simplify compound propositions. However, again, it's still on your piece of paper on the exam, so you can check it out there as well. Okay, then a very simple thing about priority. These are the rules. So not has highest priority, then and, or, exclusive or, implication, by implication. However, the only one we'd like you to remember is this negation, the not. All the others we will use brackets. So you don't have to remember the priority rules for your exam. Only know that the not has the highest priorities all times. Okay, then a very simple intermezzo. If we have a proposition with an implication, P implies Q, then we can also talk about the contrapositive. And in fact, the contrapositive is equivalent with the proposition itself, and it's defined with not Q implies not P. So P implies Q is equivalent with not Q implies not P. And with an expensive word, this is called the counterpositive. And as an exercise for yourself, just make a truth table to show that indeed what I'm saying is true. Well, if you look at the counterpositive and if we look at some exercises, then for example, the counterpositive of the first sentence, if it's raining, so it's raining is P, then I carry an umbrella. I carry an umbrella is Q, so here it says P implies Q. Then the counterpositive would be if I'm not carrying an umbrella, because the counterpositive was not Q implies not P. So if I'm not carrying an umbrella, then it's not raining. And the second one, if Barcelona does not get the Helmond Cup, then Messi did not score a goal. Don't think about what it means. In the example, just ask you to give me the counterpositive. So don't try to make sense of it. And the last one, if the sun will not shine, if the sun does not shine, not will not, then does not shine, then it's not 2 o'clock. Okay. Some other exercises. So, for instance, if Eric is a poet, then he is poor. Counterpositive. If Eric is not poor, then he is not a poet. And the last one, if Mark studies, then he will pass the test. So, if Mark didn't pass the test, then he did not study. Okay. So, that's just a signal for you. Let's make some other exercises. The question is now, check if the compound proposition is a tautology, a contradiction, or none of the two. And the easiest way to check this is just make a truth table. Okay, and let's start with the first part, so the left part of the implication, P and Q, it will give us 1, 0, 0, 0. And the right side of the implication, P or Q, will give us 1, 1, 1, 0. And then we have to finish it with the implication itself. So P or and Q implies P or Q. So then we need to remember that when the left side is false, that the implication is true. So these 3 columns, these 3 rows are quite simple. And then we only need to check out if the left side is true, then the right side has to be true as well to give us a true. Okay, this is the result. We only have ones. So if we remember correctly, that means that this is a tautology. So this complete sentence is always true, a tautology. Let's try with another exercise. So not P implies Q. Okay, looks very difficult, but let's just make a truth table. So again, we work with 2 propositions. So 1, 1, 0, 0, 1, 0, 1, 0. We start with the P implies Q. Okay, so P implies Q, that's 1, 0, 1, 1. Then we have the not P, that has a high priority. So that's 0, 0, 1, 1. And then the last part, not P implies Q. So 1 implies 2. So if not P is false, then the implication is true. And if not P is true, then P implies Q should be true as well, which is true again. So again, we have a tautology. It's always true. Quite nice. Okay, let's look at another example. P implies not Q or R. Oh dear, oh dear, oh dear. Now we see 3 propositions. So we have a P, a Q, and an R. And that means we don't have 4 possible combinations, but we have 8 possible combinations. So we have P, Q, and R. Okay, so we have 8 possibilities. So 1 0 1 0 1 0 1 0, and then Q 1 1 0 0 1 1 0 0, and then P 1 1 1 1 0 0 0 0. Okay, let's hope on your exam that we don't give you a 4th proposition, huh? Because then it really gets a long table. Okay, so now we have 8 possible combinations. So let's start with the thing between brackets. So Q or R. Q or R gives us 1 1 1 0 1 1 1 0. Okay, then we have the negation. So not Q or R, so that will give us 0 0 0 1 0 0 0 1, and then we make a combination with P, P and not Q or R, so that gives us 0 0 0 1, and then it gives us 0 0 0 and 0. Okay, so the result of this complex compound statement is that it's only true when P is true and the other ones, so when P is true, this one, and the other ones are false. But it means that there are zeros and ones in the last column, so it's not a contradiction and it's not a tautology. So it's neither of the two. Another exercise, and now they ask us to simplify a compound statement. So, and on the exam they will tell you whether it's allowed to use a truth table or not, and in this case we will do it with the help of the laws. So simplify with the help of the laws. And of course we see an implication there, and then the first law we were going to do is the switcheroo law. And so P implies Q is equivalent with not P or Q. Okay, so not is equivalent with not P, but then we need to put a not in front of it. So not P, and for me just erase them immediately. Or, and then the second part will just stay as is. So P and Q. Okay, if we have P or P and Q, and then hopefully you recognize absorption. So if we use absorption law, then this is equivalent with P. Done. That was an easy one. And if we don't trust our solution, then we can always make a truth table to check it. Huh? So we have P, Q, 1 1 0 0 1 0 1 0. Okay. Then let's first do P and Q. That would be 1 0 0 0. Then not P would be 0 0 1 1. Okay, then the last step. So we need to do not P implies P and Q. So when not P is false, the implication is true. And when not P is true, and P and Q should be true as well, which is not the situation. So this will give us 2 false. And then if we look at the columns, then indeed the result column is identical with the P column. So now with the truth table, okay, we've come to the same conclusion that this compound proposition is equivalent with P. Because of the video time, let's leave it to this. For your exam, please make sure you make all the exercises. There are plenty more in the book, and if you have any problem, please contact me through Teams or join me in a live class. So let's just finish with a small joke. The problem about being a programmer. My mom said, honey, please go to the market and buy 1 bottle of milk. If they have eggs, bring 6. And then this son, of course, came back with 6 bottles of milk. Because if they have eggs, bring 6 bottles of milk. Okay, they had eggs, so he needed to take 6 bottles of milk. Okay, hope you enjoyed again, and let's meet again for lesson 4.